is Jason from Sound Lab Cambridge. Today I'm going to talk about an algorithm that is proposed to do hearing tests efficiently. An accurate and fast hearing test is always highly desirable. However, the speed and accuracy, they are like always on the two sides of a scale. Without magic, it is impossible to improve both at the same time. An algorithm utilizing the Bayesian update is proposed to guarantee efficiency and to allow trading between speed and accuracy. There are many types of hearing tests, like the non-adaptive ones, like the classical ones, and also the adaptive ones, which they tend to change the presentation level depending on the response of the listener and trying to bracket the threshold, like the 1 up, 1 down approach and the +5, -10 approach, which is the clinical standard recommended by the British Society of Audiology and also the ASHA. And also, there are the Bayesian adaptive methods. So the Bayesian method naturally comes with an estimate and the confidence of that estimation after each presentation, after each trial. And also, if we select the step, logically, we can guarantee the efficiency of such method. So in this study, we compare if the proposed simple Bayesian update method works better compared with the BSA staircase method. The idea making EMBS efficient is actually quite simple. To gain as much information as possible, we should present the sound as near as possible to the threshold. That is because if the sound is much louder, for instance, then we can probably guess the listener is very likely to respond, even without doing the trial. So if we want to spend our time wisely, we don't want to waste a trial at a result that we can already guess before doing it. And this idea fits nicely with maximizing the feature information about the unknown threshold by changing the presentation level X. And I've done a sketch, but the key observation here is if we want to maximize the information about the threshold, we want to maximize this term. And to maximize this, we want to maximize this. And to maximize this, we want this to be 0.5. And so how do we make this exactly 0.5? By presenting the stimulus at the threshold level, we can make the probability of seeing a response exactly 0.5. EMBS takes in three parameters. First is the prior. The prior tells us about our belief regarding the threshold's distribution. And then the sigma, which is how noisy the hearing test is and how rapidly should we update our belief. And also the stopping criteria. In this case, we are using the number of trials, which is the time used for the test. And we can quantify the how good our belief is by the area overlapping between the true distribution and the believed distribution. So for instance, in this graph, we can see that the orange curve is the prior distribution and the blue curve is the true population distribution. And they are overlapping over here, which is about 50%. All right, let's do a demo of this EMBS algorithm. How does it search? So first, we start with a prior distribution over here, and then we test at the expectation of it, and determined by the threshold plus testing noise, there should be no response because the blue bar is softer than the red bar over here. So yeah, there's no response. And based on that, we can update our belief to get the posterior, right, which is the orange curve over here. And then we can check if we want to stop right after one presentation. So we don't want to stop yet. Let's do one more. So now we have a prior, which is the posterior of the first of the previous step. And we have a test over here. And then based on the response, we update the belief to get the orange curve, which is posterior. And then we check, do we want to stop? No, not yet. And then we keep doing it. A prior, a test, an outcome, and posterior, and just keep doing. And if we keep doing this for like 11 times, we can see from the initial belief, now based on all the outcomes, we now update our belief to the final posterior, which is much narrower telling us we are quite confident and also centered at the true threshold level. To evaluate the performance, 3,000 hearing tests were simulated. So in each hearing test, the goal was to estimate the threshold. And the threshold was drawn from the reported distribution from a study done in 1991. And for each hearing test, the noisiness of responses was modeled by a random sigma. So within each trial, the decision boundary is drawn from the normal distribution with the mean of theta and the standard deviation of sigma. To evaluate the performance of the algorithms, we look into three outcome measures. First is the bias, and then the accuracy, and also the percentage of unreliable tests, which is defined by the percentage of tests that the absolute error is larger than 5 dB. So for the BSA staircase method, on average, it took around 11 trials to get an estimate. And the mean error was around 2.78, which means there's a positive bias introduced by this method. And the MAE is around 3.5, and the percentage of unreliable tests was around 25%. EMBS was tested under 27 different configurations. We tested different time consumptions and also different quality of the prior, and also the different assumed standard deviation. So in this table, anything that's performing worse was marked with the red over here. And we can see overall it is performing much better than the staircase method. And if we look into individual outcomes, we can see that EMBS is less biased, reflected on the smaller mean error, and it is more accurate, reflected by the smaller MAE over here. And also, it's more reliable, reflected by the smaller number of unreliable tests. We can see when it was around 25%, but it is under 10% for the EMBS. And also, when we reduce the time used, we still have a better performance. Clinically, we can use this framework to calculate a posterior and decide if the result is good enough. We can think about the pediatric test that we never get to finish. And also with EMBS, a 6-point screening PTA can be done just under 3 minutes. So that's quite fast, quite nice. So overall, with Magic prior, EMBS improves both speed and accuracy at the same time. Thank you very much for your attention. And now I'm very happy to take any questions.